Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
When you download the Baker's app, you have easy access to savings every day. Get the most out of weekly sales and receive personalized coupons to save on your favorite items, all while earning 1 fuel point for every $1 spent. Baker's makes it easy to save while you shop, whether it's in-store or online, so you get the most value out of every trip, every time. Download the Baker's app now to save big on your next purchase. Baker's, fresh for everyone. Must have a digital account to redeem offers. Restrictions may apply. See site for details.
This is SpaceTime, Series 23, Episode 20, for broadcast on the 11th of March 2020. Coming up on SpaceTime, signs that the asteroid Vesta remained volcanically active far longer than it should have. It looks like South Australia might be back in the space race this year. And the Phantom Express project scrapped. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New evidence indicates the asteroid 4 Vesta remained volcanically active far longer than it should have. The findings, reported in the journal Geochemistry and Cosmochemistry, raises new questions about how long small planetary bodies can retain their heat after formation. The 525-kilometre-wide Vesta is the second largest object in the main asteroid belt between Mars and Jupiter. Only the dwarf planet Ceres is bigger. NASA's Dawn spacecraft visited Vesta in 2011, discovering that it has a far more complex geological history than previously thought, with a completely differentiated metallic core, silicate mantle, and thin basaltic crust. The new findings, based on argon-argon radioactive decay dating techniques, shows that Vesta was volcanically active for at least 30 million years after its formation some 4.565 billion years ago. The study's lead author, Professor Fred Jordan from Curtin University, says Vesta is the only large intact asteroid which shows full differentiation, and that makes it of tremendous interest to scientists trying to understand more about planetary formation. Jordan and colleagues analysed well-preserved samples of volcanic meteorites, which originated from Vesta and were eventually discovered in the snowfields of Antarctica. The argon-argon dating provided very precise ages for a range of Vesta meteorites, giving scientists clues about event timelines on the ancient space rock. The results show that Vesta remained volcanically active for at least 30 million years following its formation. That's significantly longer than what most models had predicted, and it was totally unexpected for such a small asteroid, which should have cooled quickly. Jordan says all the heat-providing radioactive elements should have completely decayed by that time. The findings suggest that pockets of magmas must have survived on Vesta, possibly slowly cooling as partial magma oceans inside the asteroid's crust. The meteorites also show impact dates for some of the large asteroid collisions into Vesta, which carved massive craters some more than 10 kilometres deep out of the protoplanet's volcanically active crust. The authors also identified meteorite samples from ejected debris that originated far deeper down inside Vesta, and that allowed them to better understand how long it took for Vesta's deep crustal layer to cool down. The thing is, some of these rocks were located too deep in the crust to be affected by asteroid impacts, and yet, being relatively close to the mantle, they were strongly affected by the natural heat gradient of the protoplanet, causing them to be metamorphosized. The findings suggest that the first flows of erupted lava on Vesta were buried deep into its crust by later, more recent lava flows, essentially layering them on top of each other. They were then cooked and modified by the heat of the protoplanet's mantle. The authors also concluded that the meteorites they analysed were excavated from Vesta during a large impact, possibly around 3.5 billion years ago, and were then gravitationally bound into a rubble pile asteroid, where they were protected from any subsequent impacts. A rubble pile asteroid is formed when a group of ejected rocks assemble under their own gravity, creating an asteroid that's essentially nothing more than a pile of rocks clumped together. Jordan says when combined, all these findings have provided science with a glimpse of the first 50 million years of Vesta's history. They also show how volcanism can last longer than previously thought on small protoplanetary bodies, which could mean volcanism on the early Earth may also have been far more energetic than previously thought.
Yeah, so I think this part was probably what was the most interesting for me, because I'm also a volcanologist, so I like my volcanoes, you see. And the fact that we have an asteroid that was kind of covered with volcanic rocks, that's pretty interesting. But of course comes the question on how long did this volcanism last? Because it's on Earth, it's still going. Yeah. Maybe on Venus, maybe on Mars, but on a small asteroid like Vesta, it must have been really short. So the only thing that people could do is modeling things, right? So they model the energy of the system, and they deduce how long the volcanism is going to last. Then they use also meteorites to date stuff, a bit like we did, but with a different technique, a technique which is based on zircon. So it's uranium-led dating of zircon. It is very useful, but in basaltic rocks like you have on Vesta, you don't have that many zircon. So they're very limited in what they can date, actually. So here we come with the argon-argon technique, and that is based on the decay of potassium to argon. And potassium is like bed bugs, if you want. You cannot get rid of it. It's everywhere. So that's the good thing for us. You can apply argon-argon, potassium-argon to all those meteorites. They're always going to contain potassium. And but the trick for us, the problem is that it's very sensitive to impact. So, if you look at the moon, it's been impacted so much to death. I mean, it's obvious with the number of craters. Same for Vesta. Same from everywhere, actually, in the solar system. So it's very easy.
Yeah, the light heavy bombardment has a lot to answer for.
Yeah, this one too, yeah. So the problem, it perturbs the argon chronometer. So if you're interested by impact history, argon is fantastic, but for volcanism, it's much harder. Yet, I'm very interested by volcanism. So how I do that? We look at eucrites that are called unbridged shaded. And those ones, they are very peculiar. That's the minority of those. So eucrite, what they are the basaltic rocks coming from Vesta, basically. That's what they are. And those ones, they were unbridged shaded. So that means they have not been shocked. So for people like me, they are priceless because they're going to record the pristine volcanic history of Vesta. Now, still, no matter how unshocked they are, they're still a tiny bit shocked. I know it's paradoxical, but that's how it is. Even a tiny bit of shock can perturb part of the rock. So what we did, we extracted minerals of plagioclase. So those ones, you really need a big shock to open the clock. And those clocks were not open on those meteorites, those unbridged shaded eucrites. So we could access the volcanic history of Vesta to an unprecedented level that other technique couldn't do. Because like I said before, there was no zircon or things like that. So now we try to apply that on some rocks, some volcanic rocks, and in particular, two rocks that are fossil magma chamber, if you want. So they are magma chamber in the crust of Vesta. So if you have magma chamber, you have volcanic activity, basically. You have magma, it's cooling down in the chamber. And we date those things. And yeah, they're kind of younger than what people thought with their models and previous dating. Not by much. I mean, Vesta is still so small. The volcanic activity must have ceased very, very early. But still, that's a 30 million years period time that was much longer than what people thought before. So to go back to your initial question, what's the implication for us? Now, if all the models point out to, using energy and stuff, to volcanic activity that lasts very shortly on Vesta, and yet we show it was, in fact, longer than what people thought. So what about us? Right? I didn't work on that at all. We don't have rocks. I can't date anything. It's all about model and speculation, if you want a bit. But, well, if it's true for Vesta, it might be true for us as well.
And it might be true for Mars as well. Mars should have solidified mostly. There are hints that there could still be some liquid around the core of Mars, but that's all speculation. It's, again, based on models. Could be that hints of volcanism are still going on in a number of terrestrial worlds.
Yeah, absolutely. So, look, no secret here. My favorite planet is Venus.
Well, understandably, it's. I would have thought Io would have been you.
No. Well, Io is the moon, so I like it. When I teach that to my student, I call that the pizza moon, obviously, because it looks like that. But my favorite planet is Venus. I mean, the picture we got from the surface is just It's just incredible.
And it's getting more and more likely now that we are seeing fresh volcanism, when I say fresh, within the last 100 million years or so.
On Venus, actually,
Yes.
people speculate that they saw some burst of eruption. So they're not really sure if it's, lightning or something like that, but it could be eruption, actually. So they could still be going. But obviously, because we get this giant cloud cover and the radar see only the surface, we can't see that. So we need to send more probe to Venus, in my opinion.
Oh, yeah, but getting them to survive is the problem.
As the Russian, apparently they can do it.
The Russians have done it, yes, or the Soviet Union, but yeah, they have done it, but they never lasted long. But we're a lot better than what we were in the 1970s and 80s, so hopefully we'll have a better chance now.
Yeah, that would be great.
So let's look at Vesta's history. This is all coming from these meteorite samples you got from Antarctica. What have these meteorite samples told you about the evolutionary history of Vesta?
So one of the things, obviously, was the volcanism, like we just talked about, but there was different kind of these unbreached eucrites, and one of them, that was a very deep rock that was located deep in the crust, and yet it recorded an impact. So it's not impacted after, so it's kind of still pristine, but we know based on chemistry equilibrium that it just quenched too fast for the depth. So it must have been exposed at the surface almost instantaneously. So what it means, it's like you had a giant impact, unearthing 10 kilometers of crust and just putting that into the vacuum, if you want, of space. And to me, it's kind of obvious that there were things like that happening, but seeing it in a rock, it's fascinating. And the example I like to give is like, because Vesta was still volcanically active at this time, you can imagine a giant asteroid coming and smashing into Hawaii on Earth, which is volcanically active as well. And that's the picture that you would have had at the time on Vesta. And I don't think this is scientifically very important. This is just, because I can imagine it, I find it very fascinating. If you look at the surface of Vesta, there's plenty of deep impact. So that was happening all the time. And I think as a scientific community, we focus way too much on Rhea, Sylvia, and Danaia, and we forget the rest. But there are truly giant impact on Vesta everywhere. Poor things, it's been banged up like crazy, really.
Looking at the geological history of Vesta based on these meteorite samples, what does that tell you about the main belt asteroids as a whole? They are very different in some cases, not just because they're on one or the other side of the snow line either.
Well, absolutely. But Vesta, that's the thing. Vesta is absolutely unique. It's the only differentiated asteroid still largely intact in the asteroid belt. All the rest have been shattered to pieces. So, for example, we have, iron meteorites. And even some asteroids, we think they are entirely made of iron, like Psyche, if I'm not mistaken. So that means before there were asteroids like Vesta differentiated, but they completely exploded. Vesta is the only one remaining. And even it, like I said, Vesta is pretty banged up. So a lot of so-called Vestoid asteroids, they are just part of Vesta that has been shattered from Vesta. So when you study Vesta, it really helps you understand the rest of the planet because that's the same evolution. But about the other asteroids, they're kind of different because most of them, they never differentiated. So they're still made of the primitive brick of the solar system, so-called chondritic material. So that's totally different idea. However, what you can compare the two with is the impact history. So whatever a body is made of, chondrite, basalt, as a mantle, or even iron, it's going to record impact. So all those bodies can tell you about the impact history. So Vesta is one of them. So depending where it is in the asteroid belt, you can see the bombardment history at this place. If you look at the other part of the solar system, it's going to have a slightly different bombardment history because of the position of giant planets and things like that.
In order to have differentiation, does that mean that the body's got to remain molten for longer?
Yeah, correct. So you need something to provide energy. So of course you get accretion, but because a lot of the asteroids are not differentiated, we know it's not enough. You radioactive element that's going to produce a lot of it. For example, aluminium-26 is the most energetic one. So it has a very short half-life. So that means if you get a lot of it, it decays in very short period of time, producing a lot of energy, therefore melting the system. Now, we think Vesta was not completely molten and then you had the differentiation. It was partially molten. So when people talk about big magma ocean, I think that's more like a partial magma ocean with pockets of magma and things moving around. So you see, solid rock can move. It doesn't need to be liquid. If you go on Earth, the mantle is completely solid, and yet it's fluxing, it's just moving around, except it's very slow paced over a million years. So I think Vesta was the same with the partial magma ocean and some pocket of magma. So why this volcanic activity lasts for so long? I think what happened is that some of the pocket of magma concentrate aluminium-26. So we use a definition, a so-called partitioning of elements. So some elements, they like to go in magma, some elements like to stay in solid. And apparently a different study than mine, some people have seen that aluminium-26 like to go in liquid. So it concentrates in the magma pocket and they stay liquid for much longer.
Where would you like to go next with this research?
So I'd like more meteorites, and that's why I requested more to NASA. They are really nice people, right? If you request meteorites and you do something interesting with them, they send you more. So that's good. It's been a while we're studying this. The first part of what we were doing was largely concentrated on impact. Like I say, argon is excellent for dating impact, but we tried our luck on this unbraided one, and it works. But we just did that on 7. I got some result for one in my lab, another one that works very well. So we're going to ask for more unbraided eukaryotes. Another thing we can do is the diogenite. So what they are essentially a concentrate of a mineral called pyroxene, and that's a mineral that is either you find it in the mantle or in residue from magma chamber.
Very common on Earth.
Very common on Earth, but when you have one of those from Vesta, this is really cool because it tells you what happened in the interior of Vesta.
Does it look green? That's olivine, isn't it? That's olivine, that's green.
No, unfortunately, there's not much olivine. We would like to see more olivine because that would be trace evidence, if you want, that we have piece of the mantle. The mantle must have pyroxene and olivine, but all we found is rocks with a lot of pyroxene. So we don't think it comes from the mantle, yet it must be very deep in the crust. So those ones, nobody can do much with it because it's pyroxene. So usually there's not much element to play with. And we managed to date a few of those and we get some interesting results, but that's for another day. I'm going to push my research into this direction, focusing on the stuff that are not shocked, like a few diogenite, a few eucrytes, aka basalts, and we see what we got. But we need more results, obviously, using this technique.
That's Professor Fred Jordan from Curtin University. And this is Space Time. I'm Stuart Gary. Still to come, South Australia could be back in the space race this year, and ASA, the Australian Space Agency's official headquarters, opened in Adelaide. All that and much more still to come on Space Time. It's been many decades since the last spacecraft were launched into orbit from the Woomera rocket range in South Australia's far north. But South Australia could be back in the space business this year, with a company called Southern Launch expecting to conduct its first commercial space flights from its new Eyre Peninsula launch complex before the end of the year. The company says its planned Whalers Way spaceport could eventually carry out up to 40 space missions a year. The facility near Port Lincoln on South Australia's Eyre Peninsula would launch south over the Great Southern Ocean into polar orbits. South Korean space company Perigee Aerospace has already signed up to use the facility, with some 8 launches now scheduled to fly. It hopes to launch its first rocket, Blue Whale 1, from Whalers Way in July. The 8.5-metre tall, 1,790 kilogram two-stage launch vehicle, backed by Samsung, is designed to deliver 150 kilogram payloads into 500 kilometre high sun-synchronous orbits. The company claims it can carry out its flights for just $2 million per launch. Perigee says Whalers Way is an ideal location because of minimal aviation and shipping traffic, and also because it's a long way from South Korea's belligerent northern neighbour. Once Blue Whale 1's operational, Perigee plans to develop a larger rocket capable of carrying payloads of up to 300 kilograms into low Earth orbit. Last year, the South Australian government granted the Whalers Way launch complex major project status. Southern Launch is also developing a separate rocket test range on Aboriginal land at Canimba 40 kilometres from Ceduna in the state's far west, to trial launch vehicles. It's already signed contracts for suborbital trial flights over the 145-kilometre test range, which is over land, thereby allowing for the recovery of the rockets and their payloads for post-flight evaluation. The company is now waiting for launch approvals from Australia's Civil Aviation Safety Authority and ASA, the Australian Space Agency. Meanwhile, a second company, ELA, Equatorial Launch Australia, will provide launch services for at least 4 sounding rocket flights for NASA this year from its new purpose-built Arnhem Space Centre launch complex near Nhulunbuy, 700 kilometres southeast of the Northern Territory capital of Darwin. The suborbital flights using Black Brant rockets will carry a series of scientific payloads, including spectrometers to study light spectrums from the Alpha Centauri triple star system looking for atmospheres around exoplanets, and to detect interstellar gas so as to better understand the structure and evolution of galaxies. Being just 12 degrees south of the equator, the Arnhem Launch Complex is located in what's considered an equatorial sweet spot for launching payloads into space. In fact, only the European Space Agency's Kourou spaceport in French Guiana is better, at just 5 degrees off the equator. Brazil has one even closer at just 2 degrees, but it hasn't been operational since a devastating launch pad explosion in 2003. Being on or near the equator provides launch vehicles with extra delta V or velocity when launching to the east. That's all thanks to Earth's rotation, which provides an additional 1,635 kilometers per hour compared to launch sites at much higher latitudes. And that additional boost translates into extra payload for the same amount of fuel compared to facilities such as Cape Canaveral, Vandenberg, Baikonur, or any other launch complexes in either Russia or China. ELA is also looking at providing launch services for the University of New South Wales spin-off company Skycraft, which designs and builds small satellites, including 3 new surveillance satellites for the Australian Defence Force. This is SpaceTime. Boeing has decided to withdraw from the Phantom Express experimental spaceplane program. The company's Phantom Works division had won the latest $146 million phase of the project in 2017 under a contract with the United States Defense Advanced Research Agency, DARPA, to develop a reusable winged spaceplane. The project began back in 2013 to develop a space launch system which could operate like an airline, with flights on demand, the ability to quickly service and relaunch spacecraft, and a small ground infrastructure footprint. If all that sounds familiar, it should. See, that's very similar to NASA's original plan for the Space Shuttle. However, Phantom Express was designed to be autonomous. The reusable winged launch vehicle would be about the size of a business jet. It would blast off vertically from a launch pad using a single Aerojet Rocketdyne AR-22 main engine based on the AR-25 Space Shuttle main engines. After releasing its single-use upper stage, which contains the payload, the booster would then return to the surface, undertaking a conventional runway landing. Meanwhile, after its release from the launch vehicle, the upper stage would fire up its own rocket engine, accelerating its payload into orbit. The plan was to be able to fly the same launch vehicle on 10 flights in 10 days, with running costs of just $5 million per launch, and that includes the cost of the disposable upper stage. Missions would carry payloads up to 1,400 kilograms into low Earth orbit. To prove the concept, an AR-22 rocket engine, assembled from leftover parts from the Space Shuttle program, was test-fired 10 times over 10 days to confirm it would all work. Boeing also completed fabrication of a composite liquid oxygen cryotank for the spaceplane in 2018, and according to DARPA, there were no technical barriers standing in the way of achieving its objectives. Phantom Express would fly off a refurbished Space Launch Complex 48 at Cape Canaveral, and it would use either the nearby Space Shuttle landing facility or the skid strip runway for its return to Earth. This is SpaceTime. A Russian Soyuz rocket is blasted into orbit, carrying 34 new Internet telecommunications satellites. Arianespace Flight ST-27 was launched from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan aboard a Soyuz 21B rocket. It was the 27th Soyuz mission for Arianespace to be launched from Baikonur. The 34 OneWeb satellites on board were deployed into a 650-kilometre high polar orbit over a sequence lasting some 3 hours and 45 minutes. The flight brings to 40 the total number of OneWeb satellites now in orbit. Eventually, the constellation will consist of at least 650 satellites, meaning at least 19 more flights. The plan is to have the 150 kilogram Ku-band satellites fly in 18 polar orbital planes. Each satellite has a lifespan of 25 years. This is SpaceTime. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You can even call your aunt, who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. U.S. Cellular, built for us. Visit your U.S. Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
The holidays start here at Baker's, with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
Choose from a great selection of digital coupons and use them up to 5 times in one transaction. Check our app for details. Baker's, fresh for everyone.